Hi everyone, Stephen here with an Autodesk Inventor tutorial. Today we will be creating a 2x4 Lego piece. You can see in the description the link to the PDF version of this file. However, for ease of access, I'll be using the copy within Inventor itself. So, let's begin. First, we're going to want to open up Inventor, and you'll want to select Start Working. It will take you to a screen, as you can see here, that looks just like this. Lego blocks use a millimeter system under Lego units. As we can see here, a single Lego unit is equal to 1.6 millimeters. Half a Lego unit is 0.8, 2 is 3.2, so on, so forth. The Lego unit system will be critical in your success when working with Lego blocks in Inventor. Almost all Lego blocks, if not all of them, use in some way a denomination of the Lego units. Remember this, it will be handy later. So, back to where we'll be beginning. Because the Lego blocks always use a millimeter system, again, Lego units plugs into millimeters directly, you'll want to create a new folder under millimeters. To do this, simply hit New in the top left of your home screen, go into Metric, go into English US, then Metric, and then select a standard millimeter IPT file. Double-click that, and you can begin your work. Just give it a moment, as it often takes time to load the first time you open the file. So, to begin, you will want to create a 2D sketch. This is the basic of all Inventor files, and operates quite similarly to Autodesk AutoCAD. In order to begin creating a drawing, you first must select a plane. In our case, it doesn't really matter which plane you select, so simply choose one and begin. By selecting a plane, you'll be taken into the Sketch interface. The Sketch interface allows you to draw using lines, circles, arcs, rectangles, and many other tools in order to create a 2D drawing of whatever it is that you'd like to create. In our case, we will begin by selecting the rectangle tool up in the sketch bar and creating the base of our Lego block. As we can see in here, the base will be 16 by 32 millimeters. So we take the rectangle tool, click it really anywhere. In my case, I'll select the origin point 0, 0. However, it does not matter, and type in 16 tab 32. Hitting the tab key, you're able to specify a dimension very quickly without needing to manipulate your mouse at all. We can now hit enter, and our dimensions will be translated. If you were to draw a rectangle by clicking once and clicking again, and create one at random measurements, that is also alright. The dimension tool can then be used by selecting either two vertexes and then dimensioning and entering in an appropriate dimension, or by selecting a line, clicking, and punching in the appropriate dimension. This is also an acceptable way to create your dimensions. However, seeing as I already have one at the proper dimensions, I'll simply click this and bleed it away. Now that we have our appropriate rectangle, we can click Finish Sketch and be returned to the 3D interface. On this plane, we now have our 2D sketch of a 16 by 32 rectangle. Now, in order to give it a third dimension, we will want to go up to the 3D model ribbon and select the extrude feature. Since the rectangle is the only existing shape, the extrude feature will automatically snap to it. However, seeing as this is not always the case, it's good practice to first click extrude, then click the object which you would like to extrude. If you would ever like to change the profiles which you're extruding, you can simply select them here by clicking this and then clicking whichever shapes you would like to extrude. As we can see here, The height of the main body is 9.6 millimeters. In other words, 6 Lego units. We will now extrude the rectangle to equal 9.6 millimeters by simply clicking the box and typing it in. We can now press enter to complete the extrude. Now that you have your rectangle, the body, as it were, is complete. However, it is lacking the interior as well as exterior studs required in order to make this a true Lego block. Next, we will add the studs. As we can see, the studs are 4 by 2 in an array, each 8 millimeters apart. This is, of course, the standard of a 2 by 4 Lego block. We can also see that as a result of these being equally spaced apart, 8 millimeters apart each, they must logically be 4 millimeters in from each corner, or each edge rather. Using this information, we can create a new 2D sketch on the top of the block. Simply select Start 2D Sketch and click the top to select the top face as your plane. After doing this, it's possible to rotate this as you like to simply get the appropriate angle, and we can place a circle on the top. Now, there are multiple ways you could go about doing this. You could, if you wanted to, although this is bad practice, simply go in 4 millimeters, 4 millimeters. Oh, see, that didn't work. Bad practice. But you could go in 4 millimeters and 4 millimeters, and then place your circled center point on that and create the appropriate 4.8 millimeter diameter circle at that point. As we can see, 4.8 millimeter diameter. However, this is not perhaps the most appropriate way of going about this. So instead, we will delete this and perhaps try a new way. One such way is to create a circle of your 4.8 millimeter diameter at really any point you so choose. You can then use the dimension tool to dimension an appropriate distance. 4.8, no, 4. 4.8 is the diameter. My mistake there. And 4. Then you have your appropriate distance. You could, of course, wait until later to do this. However, it is good practice to begin with one of these ways. Now that we have our first circle set at an appropriate distance, we must create the rest of the array. The way we'll be doing this is through the rectangular array or rectangular pattern tool. There are two ways of going about this. I will first demonstrate the one which is rather inefficient. If you're following along, please stop now and simply watch, as following this process will simply waste your time. We can begin by selecting the circle through rectangular pattern, click that, and if it hasn't automatically selected it, select geometry, and then select the circle. The circle will now be highlighted blue, geometry should turn white. You now know that this has been appropriately selected. We can now choose our directions in which we would like to repeat this. So we'll select direction 1. That red mouse button is the tool which indicates that you're selecting that direction, and select this axis. By clicking this line, we've now indicated that along this axis we will be setting our direction 1. Seeing as the arrow is pointed this way, you can see that faint outline, it's currently facing the wrong direction. So we'll simply hit the flip button in order to make it go in the correct direction. We can now select direction 2, click that line, and now we can see that it's going in the correct direction, so a flip is unnecessary. Now, of course, this doesn't look quite right. We can see back in here that each circle is supposed to be 8 millimeters apart. However, by default, they are 10 millimeters apart. So we will simply reselect this and punch in 8 millimeters. Now we can see they're at the appropriate distances. However, there are too few columns in this array. So Now that we know that this is direction 1, as we selected earlier, we can simply change the direction 1 value to 4. This will create 4 columns in sequence. We can now simply press OK, completing this array, and finish the sketch. You can now select the extrude tool and extrude, holding Control in order to select multiple. Extrude every single one of these. Now, of course, these are far too tall, and so we'll come into the drawing and select, or not select, my apologies, we will view the correct height, that being 1.6 millimeters. So now we can, of course, punch in 1.6 millimeters, press enter, and now we have our studs. This, however, is far from the most appropriate manner of doing things. So I'll simply hit Control Z, undo, and go back to where we began. Now, the most efficient way to do this that I am aware of is to simply finish the sketch and only have the one stud. We can now extrude the stud to our 1.6 millimeters. As it was the last value used, it autofilled, so we can simply hit enter. And now we can use the rectangular array or rectangular pattern tool and actually select the extrude itself, that whole feature. We can now take the top view, select direction 1, and select direction 2. Direction 1 is running in the wrong direction, so we will simply flip it, change our values to 8 millimeters instead of 10, and of course change the amount of columns to the appropriate number. Now that we have completed that pattern, we can see the extrude has been repeated the appropriate number of times at the appropriate spacing without us needing to repeatedly select things. Next step is to create the shell of this. As we can see in the drawing, the shell thickness is 1.2 millimeters. In order to achieve a shell of the studs and the shell, and the body rather, and as we can see, the body is indeed, or the studs are indeed shelled as well as the body. We simply go down to the bottom of the piece and we select the shell in the ribbon, the 3D model ribbon. After selecting shell, we can now see that it will generate one on the entire body. So we'll simply click the bottom face in order to create an opening at the bottom. Whatever face you click on selects it as the opening to the shell, as it were. We may now simply punch in the thickness we desire, being 1.2 millimeters. Pressing OK, it will complete the shell operation, and as we can see, it has both created a shell along the border as well as within the studs. Next is to create these tiny extrusions along the edge of the walls. As we can see here on the break, these tiny extrusions are 0.4 millimeters in width. Additionally, these tiny studs, or not studs, rather extrusions, are perfectly touching the edge of where a stud might insert if the part were to be pressed into one of its identical. In other words, this stud, the outside of it, will mirror perfectly down and they will touch. In order to create these extrusions, we will once again need to start a new 2D sketch. Beginning the sketch, and of course orienting to your preferred angle, we may now use what is called the Project Geometry tool. By pressing Project Geometry, you can select geometries that would not otherwise be visible. I have, of course, repeatedly done this for the sake of accentuating my point. However, doing it this many times is not necessary. In essence, this will highlight borders which otherwise might not be visible. After we've appropriately highlighted our geometry, I will, of course, delete the unnecessary geometries. We can begin placing our extrusions. In order to do this, there are multiple ways to go about it. However, my preferred method is to simply take a line and draw it up, of course ensuring that the degrees are set to appropriate perpendicularity, in this case 0 degrees, and simply draw it up to the line which we desire. We may now use that point to draw 0.2 millimeters, of course remembering that, excuse me, that it is 0.4 millimeters across, so of course half that, 0.2, seeing as this is the center, and simply then draw a rectangle coming down. Any distance will do. However, we need to ensure that this measurement over here that you can see I've tabbed into is 0.4. We may now press enter. Now, as you can see, these lines are black. This means that they are constrained fully. They cannot move. However, this line is purple. It is currently half constrained, as it were, or partially constrained. These yellow lines, of course, are projected, so they do not reflect constraint. So, this constrained line is simply, or partially constrained line, is simply perpendicular to this and parallel to this line. It, however, can move freely however it likes from here. If I can get the vertex to select. Well, no matter, it can move. There we are. So, in order to properly constrain this to the appropriate length, we will simply take the constrain tangent tool, select the line, and select the outside of the circle which we would like to constrain it to. This will create a perfect mesh between the two lines. Now that we have our extrusion completed, or rather the 2D version of it, we may finish the sketch and complete the outline of it. As we can see, it's up against that back face. However, it is still on the inside of the shell. We'll now zoom in, press the extrude button, and select the two halves. Because there is that center line running along, you need to select both halves. Now then, as you can see, if we were to extrude this, it would be a rather strange number. You could, in theory, manually punch in 9.6 minus 1.2, 9.6 tall minus 1.2. That would bring you to the appropriate height. However, to save time, you can instead simply select the 2 feature. As we can see, they do indeed reach all the way down. These are the small extrusions in here. We can see that they reach all the way down, so you can simply hit the 2 distance and then select the face which you would like it to go to, in this case the bottom. It will make it perfectly flush. We can now press OK, and the extrusion is complete. Now we will simply repeat the process for the other direction, projecting the geometry of that large circle, drawing our line all the way up, of course ensuring that those degrees are locked in. Now draw that second line of our point. Oh my, I appear to have forgotten. Point 2. A reminder, if you do not have it pulled up and you are following along, the PDF version of the drawing which I'm using is available for free in the description. Simply click the link available there to download it. We may now draw our rectangle, ensuring that it's constrained to that line, 0.4 width, right about any length. We may now take the constraint tool, constrain to tangent, clicking that line, and then the tangent, and constrain it appropriately. We may now finish the sketch. Press extrude, select both the halves, and mark it 2. Press OK. And now, as you can see, we have 2 nicely constrained little boxes. Okay, now for the fun part. As you can see here, these lines only get you so far. They haven't gone across. They don't go to the ones adjacent them. They're honestly quite useless in this state. And so, we will use that rectangular tool once again to translate them further down the line. First, we will do this one on the widthwise axis, simply selecting direction 1. We do not require direction 2 in this case, as we're not creating additional rows, simply an additional column. And we will, of course, flip it to go in the appropriate direction. 8 millimeters, and press OK. We now have this axis completed on this side. We may now, of course, repeat this for this extrusion over here. We select the rectangular tool, select the extrusion, or it can be difficult. Seeing as it doesn't want to cooperate, you can instead select extrusions and really any other features and functions on this side directly, as well as though you were clicking the part physically. They operate the same. Select your direction, punch in your direct length, the appropriate number, in this case 4, and press OK. Now that was actually a rather important note to make. These parts or features, as it were, can be directly selected along this line, or along this bar rather, the column, the ribbon, whatever you'd like to call it. And they can be modified, selected, and altered however you might like through this menu directly. So now we have this side over here completed, and this side over here completed, but of course we don't have the mirrored side. A quick way to remedy this is simply by utilizing work planes. Seeing as we know that this is a 16 by 32 millimeter block, we can simply select a work plane, click and hold, and make this, again, 16 long, or 16 wide rather, so we can make it -8. And that will place a work plane directly in the middle. Now what these work planes do is you can select them and work on them as though they were any other axis. Again, 2D sketches, perhaps, might be useful on this. We can, of course, place a secondary work plane going lengthwise, or widthwise rather, at -16. That creates 2 center work planes, one going lengthwise, one going widthwise. Now what we can use these for instead of a 2D sketch, however, while it may be useful for perhaps bringing something off the center otherwise, in our case, we will instead be using it to mirror. So what we will do is select the mirror tool up here next to the rectangular pattern. Select our features. In this case, we will be selecting extrusion 3, holding control, and pattern 3, rectangular pattern 3. Select the select mirror plane cursor, and select the appropriate plane. In this case, work plane 1, the one that runs lengthwise. We may now press OK, and they've been appropriately mirrored. We may now press, again, the mirror tool, and select extrusion 4 and pattern 2, our appropriate extrusions. Select the mirror plane select, and then select the appropriate mirror, work plane 2. Press OK, and now these extrusions have been appropriately positioned and mirrored. Next up is to create these internal cylinders. These are actually extremely straightforward to create, seeing as they are tangentially constrained to each of these studs, or rather, not the studs themselves, but the projected geometry of them. And of course, they run the entire height of the internal shell. So returning to part 1, we can begin a 2D sketch on the top of the inside and simply project the geometry of 4 of these circles. We may now create a circle at right about anywhere within this at any size, seeing as we will soon be constraining it. You can just hit enter. Now we will select the constrain tangent tool and simply constrain each of these circles to one another. The 4th one is unnecessary, however redundancy will allow you to double check that everything has been perfectly positioned. If the constraint of the last 2, so the 4th and of course the 1st circle, is rejected, something is amiss. Now, of course, this is not a standalone circle. No. Instead, it is a circle which has another one in it in order to create a tube within the Lego piece. Now, as we can see, it is a 6.51 approximate diameter of the external circle. We can, of course, confirm this with the dimension tool. The dimension tool is not only for constraining, but also for legitimate dimensioning. So, as we can see here, 6.514. That is correct. Now, we can take this 4.91 and figure out the appropriate thickness of this. In this case, the appropriate thickness of this tube will be 1.6 millimeters. Sound familiar? In order to gain a more accurate diameter, we can simply extend this to the existing cylinder, and rather than manually punching in 4.91, instead take the value presented to us by the more precise measurements auto-generated in Inventor and simply press -1.6. Inventor will now automatically calculate the precise measurements required in order to create your new circle. Pressing enter, we can see that it is being created at the precise measurements required. We may now finish the sketch, press the extrude button, select that inner tube, and then select 2, the lower face, and press OK. The support tube has now been created at the appropriate measurements, at the appropriate position, to the appropriate height. Now, of course, there are 3 of these, but following suit with the current pattern, they're each 8 millimeters apart, so creating an additional one is unnecessary. We can instead, once again, use the rectangular pattern to simply translate them down the line 8 millimeters apart. In order to double check this, I'll simply prove to you that this has properly functioned through beginning a 2D sketch and simply projecting the geometry of multiples of these circles. And as you can see, they perfectly line up. I will, of course, delete this sketch as it is unnecessary. The next step will be to install this bar running along the width of the Lego piece. This is, of course, a support piece in order to prevent the cylinder from being destroyed if one were to install a Lego piece at an awkward angle or exert pressures upon it. To do this, it's quite similar to the extrusions, which hold the studs in place when a block is stacked. Simply begin a 2D sketch, select the interface, and project the geometry of that inner circle, or rather the pair therein. Additionally, projecting the inside of the shell is not a bad idea. We may now, of course, press right-click, hit OK, and then pull up this radial menu by hitting right-click once again. By hitting OK, you have exited out of the Project Geometry tool, and right-click has opened up your radial menu. We may now slice graphics in order to see appropriately what we are doing. By slicing graphics, it has removed any objects between the screen and the plane which was selected for our drawing. We may now draw a line traveling from one side midpoint. Of course, this lighting up green indicates that it is the appropriate midpoint of here until here, all the way up to the other midpoint. And to confirm, we can see that it is 180 degrees. This black line indicates that it has been fully constrained through a midpoint to a midpoint. This cannot go anywhere. Now, as we can see, this line is not let me reattempt that. This bar is not positioned with any one line on a midpoint. Rather, its midpoint is the midpoint of the lengthwise direction. And of course, is at a width at 0.8 millimeters. We can now simply draw a line traveling 0.4 millimeters, and then a rectangle traveling from one side to the other, 0.8. Please note that this may not be the cleanest way to go about this. Using the dimension constraint between the line and another line is far cleaner. Or using the following tactic may be a cleaner result. To demonstrate a slower, albeit more professional method, instead leave this line where it stands and you utilize the offset tool. By pressing offset and then selecting a line, you can see that it creates a phantom version of it. We may now select a distance, in this case 0.4 millimeters, in which direction we would like to set it. By pressing enter, we've created an offset at 0.4 millimeters, as you can see here. Now we may offset again from the center at 0.4 millimeters, or we may offset from the first offset at 0.8 millimeters. This has created an appropriate bar, appropriate constraints, with arguably fewer steps. Honestly, it's up to you which you would like to use. However, learning the offset tool is extremely convenient, especially when offsetting larger structures, such as, say, an entire shell, as you can see here. If you would like to keep things clean, we may now use the trim tool in order to trim off the overlapping lines that bleed into the circle. This will perfectly cut them along that line of the circle, creating a perfectly clean extrusion for later. However, this is an optional step, as due to you having projected the geometry, they have been selected as separate zones anyways. So honestly, this is simply for if you come back later and need to make an edit. Either way, we may now finish the sketch and extrude these lines. if one were to delete that center line, you would lose your constraints. However, you would only need to select 2 boxes. Now, as we can see here, this does not actually travel from the top to the bottom. It is offset by 2.4 millimeters from the bottom of the Lego block. Once again, if you feel lazy and don't want to calculate the 1.2, that being the distance from the top to the shell, and then the 2.4 millimeters to the bottom, we can simply take this distance, put in 9.6 millimeters, that being from bottom to top, minus 1.2, the top to the shell, minus 2.4 millimeters, and you will get your appropriate height. Now, of course, you could simply put in 3.6 millimeters, but where's the fun in that? Congratulations on assembling your first ever LEGO 2x4 block. In subsequent videos, I'll be explaining how to turn this block into a modular design, as well as how to use it in subsequent assemblies. Look forward to videos pertaining to our upcoming drone project, and other tutorials as to how to interface with Inventor and become more masterful with it. Thank you very much for watching my first ever Inventor tutorial. I look forward to making more. Have a wonderful day.